Hello, my name is Anna, and in this video I will talk about tree data structure and explain what is binary tree and binary search tree. I will describe why trees are important and show you many operations you can do on trees. In the second part of this video I will show you how to code tree traversal algorithm using Java programming language. Imagine this. A company with 50 employees is going to build their own office building. The company wants to have modern technology installed in their smart office, like information system and employee management. The building should have underground parking for 50 parking spaces and separate room for different departments. For parking, we can use simple data structure like array because it is fixed in length and spaces in the parking will always be the same. However, employees' number and their positions can change, thus we need hierarchical data structure. This is where tree data structure comes to help. What is tree data structure? A tree in programming is similar to family tree, where we have senior member of family or general director on top and other family members or employees down below. While array or linked list are linear data structures, tree is hierarchical data structure. There are many different kinds of tree in programming, like binary tree, binary search tree, complete binary tree, full binary tree, perfect binary tree, balanced tree, AVL tree, and regular tree. And there are many different operations you can do on trees, like traversal, insert, search, and delete. Each kind of tree has its own specification. For example, AVL trees are more strictly balanced, and hence provide faster lookup. Thus, for a lookup intensive task, use AVL tree. For insert intensive task, use red-black tree. Let's say we have to build a program for a company. The company employees have different tasks and positions, therefore we can put them all in one class. We create abstract class and make subclasses for director, manager, full-time staff, part-time staff, and so on. Remember that abstract class cannot be declared as final. Now we need to build tree data structure so the company can add employees' names. Software development requires using various programming tools, same like for example building wardrobe. To build a wardrobe you will need wood planks, nails with hammer and instruction. To build a program you will need language, syntax, data structure with algorithms and an object-oriented programming paradigm. That is why except Java programming language you should know object-oriented programming, data structures and algorithms. You can build wardrobe if you don't have wood planks, or you have wood planks but you don't have nails. Same with programming. If you only learn Java syntax but don't know programming algorithms, you can build a good program. If you put doors upside down, you can use wardrobe. If you write wrong code, you can build good software. When building software, a programmer has to take various things into consideration. What type of data needs to be stored? What is the cost of operations? What data structure utilizes less memory? Here is short notice. If you want to start learning programming, the best is to learn Java syntax in the beginning and master Java core. Next, learn about object-oriented programming, what is abstraction, encapsulation, inheritance, polymorphism, and then learn about data structures and practice programming algorithms. If you want to learn it fast, you can do it in 3-4 months. Let's get back to the tree. What is the difference between binary tree and binary search tree in programming? Every tree consists of nodes. Each node contains some data like integer, string, and the link to or reference to other nodes, similar to linked list. Each tree has its root. It is the topmost node of the tree. If node that doesn't have any parent, it's root of the tree. Parent is a node that contains any subnode. A descendant of a node is called a children node. The node of the tree which doesn't have any child node is called a leaf node. A leaf node is the bottommost node of the tree. If you want to create binary tree whose nodes are storing integer data type, we create class called node. Then we add node with integer data type and left and right child. As you remember from our previous video, word binary means consisting of two things or parts, a choice between two alternatives only. You already know what is binary search. Now let's learn what is binary tree and how it's different from binary search tree. Binary tree is tree data structure that consists of two children at most, just like Indonesia government program Dua Anak Cukup. So for example, this is binary tree and this is binary tree, but this is not binary tree. Binary tree can store different data like integer or string, but in one tree all data has to be of the same kind. As I mentioned in the beginning, in this video there are many kinds of binary tree. And what is binary search tree? Binary search tree is a special kind of tree where all left nodes are smaller than root and all right nodes are bigger than root. With this structure, binary tree allows fast data lookup. If you want to search for a key, we check the root node. If our key is smaller, we search in left subtree. If it's larger, we search in right subtree. The name of this tree actually comes from binary search because it allows fast search. Remember that every binary search tree is also a binary tree, but not every binary tree is binary search tree. And binary tree, same like linked list, is recursive data structure. It means that a part of a tree is another tree. That's why recursive algorithms work best with trees. From office building, let's move to Java Jungle and do some tree traversal. What for you might want to traverse a tree? You might, for instance, want to add all the values in the tree or find the largest one. Traversing a tree means visiting each node in the tree. There are many ways to traverse the tree, but these are the most popular: preorder, inorder, and postorder. When doing traversal, we always visit left side first and then right side. The prefix in the name tells us when we visit the root. Pre in the beginning, in the middle, and post in the end. If you know how to traverse binary structure, it becomes much easier to solve problems recursively with a stack. The inorder traversal is special because it prints nodes in a sorted order. Inorder traversal is a depth-first algorithm. It explores the depth of binary tree before exploring siblings. During the inorder traversal algorithm, the left subtree is explored first, followed by the root, and then finally the nodes in the right subtree. To implement this algorithm, we write a method to traverse all nodes of binary tree using inorder traversal with following steps. Write a method, write a base case, visit the left subtree, print the value of the node, traverse the right subtree. If you want to implement the preorder or postorder traversal, the algorithm is the same. You just need to move position of root node to top of bottom. Now let's see how to code traversal in Java programming language. Open your favorite IDE and create new project. The class is usually called node. Next, we coded the preorder, inorder, and postorder algorithm. Then in our main method we create binary tree and assign values to it. Now we can print preorder, inorder and postorder traversal. The idea behind binary search tree is similar to binary search. If you assigned integer 50 to the root, then left child will be 25 and the right child will be 75. The leaf nodes will be accordingly 15 and 35 on the left and 62 and 88 on the right. Now we can search for integer 88 just like in binary search. You can see that inorder traversal gives us result in sorted order. If you want to learn programming by yourself, in the beginning you might be confused what actually you should learn, which programming language you should choose and how to start. In this video series I will show you that programming can be easy and actually fun. Let's learn together. Please subscribe the channel so you don't miss any new video. Thank you for watching.